The Great American Mystery. It is the ultimate backyard staple, yet it is shrouded in more urban legends than almost any other food on Earth. Don't ask what's inside is the common refrain. But in the world of high-volume food engineering, there are no secrets, only highly optimized chemistry. In the United States alone, people consume over 20 billion hot dogs a year. To meet that demand, factories have moved away from traditional butchery into a realm of high-shear emulsion and high-velocity extrusion. Today, on Process Sector, we are pulling back the plastic to see exactly how beef, pork, and spices are transformed into the world's most consistent sausage. We're going inside the massive facilities of Oscar Mayer and Nathan's Famous to see the 300,000 link-per-hour machines in action. Before we see the meat, we have to understand the science. A hot dog isn't just a ground sausage, it is a meat emulsion. Much like mayonnaise or a latte, a hot dog is a mixture of two things that don't usually stay together: fat and water. The Process Sector secret is to bind these together using protein as the glue. If the factory gets the temperature or the speed of the blades wrong, the fat will separate, and the hot dog will be oily and unpalatable. This is a masterclass in food stability. Raw materials and the pre-blend. The journey begins with trimmings. Contrary to the myths, these aren't mystery parts. They are high-quality cuts of beef and pork that are left over after steaks and chops are removed. The meat arrives in 2,000-pound stainless steel bins called combos. Every batch is sampled and tested for lean-to-fat ratios using X-ray fat analysis technology. To create a consistent hot dog, the factory must ensure the meat is exactly 70% lean and 30% fat. If it's too lean, it's dry. If it's too fat, it won't hold its shape. This is where the magic, or the science, happens. The meat is dumped into a massive machine called a silent cutter, or a vertical high-shear mixer. Instead of just grinding the meat, this machine uses blades spinning at 3,000 RPM. As the blades chop the meat into a fine paste, the factory adds slush ice. Why ice? The friction from the blades is so intense it could cook the meat. The ice keeps the temperature below 7 degrees Celsius, which is critical to keep the protein stable. During this 5-minute cycle, salt, corn syrup, and spices, like garlic, mustard, and paprika, are added. The result is a smooth pink batter that looks more like cake frosting than steak, the extrusion, forming the links. The batter is pumped into a stuffer. This machine is an engineering marvel that can process 800 hot dogs every minute. The meat is forced through a nozzle into a casing. In industrial factories, they don't use animal intestines. They use cellulose casings made from plant fiber. These casings are like long translucent tubes that can be miles long. A mechanical twister snaps the long tube into uniform links. Every twist is calculated by a computer to ensure the hot dog is exactly 13 centimeters long. These chains of hot dogs are then draped onto massive smokehouse trees, racks that can hold over 20,000 hot dogs at once. The smokehouse and thermal processing. The racks move into a multi-stage smokehouse. This is a 100-meter-long tunnel where 3 things happen. 1. Drying, hot air sets the protein on the surface of the meat. 2. Smoking, natural hardwood smoke, usually hickory or maple, is atomized and blown over the links to give them their iconic flavor and reddish-brown color. 3. Cooking. A steam injection system brings the internal temperature of the hot dogs to exactly 71 degrees Celsius. This kills any bacteria and sets the emulsion into a firm, bouncy solid. The peeler becoming skinless. Most hot dogs you buy in the store are skinless, but we just saw them being stuffed into cellulose tubes. How do they get the skin off? After cooling down under a cold water shower, the chains move through a peeler. This machine uses a tiny laser or a sharp blade to make a microscopic nick in the cellulose casing. Then, a blast of compressed air literally blows the skin off the meat. The casing is vacuumed away for recycling, leaving behind a perfectly smooth, firm hot dog. This happens at a speed of 12 feet per second, too fast for the human eye to track. The brine chill and final check. The peeled hot dogs travel through a brine chiller. This is a bath of salt water cooled to -5 degrees Celsius. This flash freezes the surface, which locks in the moisture and gives the hot dog its snap when you bite into it. Before packaging, they pass under an optical sorter. High-speed cameras look for any rejects, hot dogs that are bent, have air bubbles, or are the wrong color. These are kicked off the belt and diverted into a rework bin. Packaging, vacuum and nitrogen. In the final process sector stage, the hot dogs are aligned by vibrating plates into rows of 5 or 8. They move on to a thermoforming machine. This machine takes 2 sheets of plastic film. It heats the bottom sheet and vacuums it into a tray shape. The hot dogs are dropped in, and then the top sheet is applied. But before it is sealed, the machine performs a gas flush. It sucks out all the oxygen and replaces it with a mixture of nitrogen and carbon dioxide. This is why hot dogs can stay fresh in your fridge for weeks without preservatives. The lack of oxygen prevents spoilage. The journey of a hot dog is a story of total efficiency. From the high shear emulsion that turns meat into a stable batter, to the laser peeling machines that move at the speed of sound, it is one of the most highly automated processes in the food world. It might be a mystery to some, but to engineers, it is a triumph of consistency. So, are you a fan of the classic snap of a natural casing? Or do you prefer the smooth, uniform, skinless variety? And do you take yours with mustard? Or are you one of the controversial few who use ketchup? Let us know in the comments. If you found this deep dive into the process sector satisfying, hit that like button and subscribe. We're moving from the grocery store to the construction site in our next video. You won't believe how they manufacture giant steel excavator tracks.